Welcome, my dear students in Prep 3. We are still in Unit 2. Today we will talk about continued proportion. We studied before what do we mean by proportion, and we studied properties of proportion and some proofs. Today we will study continued proportion. In continued proportion, we have, for example, here we have three numbers. In continued proportion, if I have A, B, and C, we said that A, B, and C are continued proportion if A over B equals B over C. Okay, in this case, we call A the first proportional and C the third proportional, while B is the middle proportional or the proportional mean. So B power 2, if we make a cross product, B times B equals B power 2 equals A times C. So if you want to get the value of B, you will take the square root of AC, positive or negative square root of AC. Okay, here for example, in this case, as we said before, if I want to get the middle proportional, which is B power B, I'll take the square root of AC. Okay, so A and C should have the same sign because here I have a square root. There is no negative number inside the square root. Can't be. Okay, there is no square root for a negative numbers. So if I want to get B, the middle proportional, the two numbers A and C should have the same sign, either both positive or negative. So for any two positive or two negative numbers x and y, as a first and third proportional, there are two middle proportional. The first one is positive root xy, the second one is negative root xy. So if you want to get the middle proportional B, for example, it will be positive or negative the square root of AC, first times third. Here for example, the first one, find the middle proportional between 32 and 18. I want the middle proportional, so I will take positive or negative square root of 32 times 18. 32 is the first proportional and 18 is the third proportional. Okay, so I'll take positive or negative square root of 32 times 18, which is positive or negative 24. Number 2, find the first proportional of 8 and 16. I want the first proportional, so I don't have a first proportional. So in this case, 8 is the second proportional. 8 is the second proportional and 16 is the third proportional. So what do we have here? We want the first, so the first proportional is A. I don't know A, but here the second proportional or the middle proportional is 8, so A over 8 equals, this is the middle proportional, so I write 8 again over 16. It means if I want to get A in this case, if I want to get A, I'll multiply 8 times 8, then I'll divide by 16 using cross product. So A equals 8 times 8 over 16, which is 4. Okay, so in the first exercise here, we calculate the middle proportional by taking positive or negative square root of first proportional times third. And here we want the first proportional. So multiply the middle proportional by itself over the third proportional, which is 60. As we do before in proportion, we have A over B equals B over C. In this case, I'll assume that A over B equals B over C equals M, a constant number. So if I want to get A, I'll multiply B times M. If I want to get B, I multiply C times M. So A equals BM and B equals CM. In this case, I can also substitute here. Instead of B, I write CM. Instead of B, I write CM. So I have CMM. A will be C times M times M. It means CM power 2. So I'll use in continued proportion B is the middle proportional equals Cm, and A, the first proportional, equal Cm power 2. I used the two forms here in proof to facilitate the proofs. Let's take this exercise. Here, for example, I have if A, B, and C are continuate proportion, prove that 3C power 2 minus 4B power 2 over 3B power 2 minus 4A power 2 equals C power 2B power 2. I can use the symbols or the forms before. A equals Cm power 2 and B equals Cm. Instead of each B, I write Cm. Instead of each A, I write Cm power 2. So here what do we have? We have 3C power 2, I write it as it is, minus 4. Instead of B power 2, I write, this is B, Cm. So B power 2 equals C power 2, M power 2. In the denominator, I have 3B power 2 minus 4A power 2. Instead of B, I write C power 2, M power 2 minus 4. Instead of A power 2, I write, this is A, C, M power 2. So I write C power 2, M power 4. Because power 2, all power 2 equals 4. Then I'll take a common factor. Here in the denominator we have, in the numerator I have C power 2. I write C power 2, then I'll divide both terms by C power 2 to get 3 minus 4M power 2. Here we have a common factor, C power 2, M power 2. If I'll divide both terms by C power 2, M power 2, I'll get 3 minus 4M power 2. Okay, I can simplify. Here I have 3 minus 4m power 2 over 3 minus 4m power 2. Okay, here I have C power 2. What about here? I have C power 2 m power 2. C power 2 m power 2 is the same as B power 2. So this is C power 2 over B power 2. Okay, you can use another method by simplifying the right hand side also. Okay, this is the right, I can simplify the right hand side. Here for example, instead of C, I'll write C power 2, and here I write B power 2 as C power 2 M power 2. Okay, so the right hand side will be 1 over M power 2, 1 over M power 2, and I can simplify from here, from this here, from this step I can simplify it to be also 1 over M power 2, the same. The two methods are the same. So in both cases, left hand side equal right hand side. Okay, let's continue. Okay, if you have more than two equal ratios, for example, here I have A over B equals B over C equals C over D equals a constant which is M. Okay, what do we have here? We want to simplify, so I write C equals dm. Look at here, C equals dm. B equals cm. Cm, it means dm power 2. What about A? bm. A equals bm, but B equals dm power 2. So A equals dm power 3. Okay, let's explain it again. We want to explain this again. Okay, here for example, I write C equals dm. Okay, the first one is very easy. Okay, let's move to B. B, look at here, B equals cm. B equals cm. cm. But I have here C equals dm. So I write B equals, instead of C I write dm. So I have d m, and here also another m, so it will be dm power 2. So B equals dm power 2. Okay, let's go back to A. A equals what? A equals bm. A equals BM. Okay, but we have here B equals dm power 2. Okay, B equals dm power 2. So I write instead of B, dm power 2. dm power 2. And I still have another m. So A equals dm power 3. And this relations, we will use this relations in some proofs. Okay, so generally in continued proportion, C equals dm, B equals dm power 2, and A equals dm power 3. Okay, if A, B, C, and D are in continued proportion, prove that A plus 2B over B plus 2C equals C plus A over D plus B. Okay, we know that in this continued proportion, A equals dm power 3, B equals dm power 2, and C equals dm. So I'll substitute in the left hand side and the right hand side by A and B and C. Then I want the left hand side to be equal to the right hand side. Let's start with the left hand side. In the left hand side we have A plus 2B over B plus 2C. Instead of A I write dm power 3. Instead of B I write dm power 2, and instead of C I write dm. Okay, now I have a common factor in the numerator, which is dm power 2. So I'll take it as a common factor. In the denominator I have dm. Also I'll take it as a common factor. So now I have dm power 2 as a common factor up here in the here in the numerator, dm power 2. So here the remainder after dividing it will be m, and here also it will be 2. So m by 2 plus 2, sorry. And the denominator I have dm as a common factor. So I'll divide both terms by dm. It will be m plus 2. Now I can simplify m plus 2 and m plus 2, and d with d divided d equals 1, and m plus 2 divided m plus 2 equals 1. And here m power 2 divided m, I subtract powers, so it will be m power 1 or m. So the left hand side is m. Okay, what about the right hand side? Let's see now the right hand side. Let's move to the right hand side. By the same way, C plus A over D plus B. Instead of C I write dm, instead of A dm power 3, and instead of D I write D as it is, and instead of B I write dm power 2. What is the common factor up? I have dm, yes, excellent. So dm, yes, times 1 plus m power 2, and in the denominator the common factor is d only. Okay, so it will be d times 1 plus m power 2. Now I have 1 m plus m power 2 here. 1 plus m power 2 equals 1, and here d divided d equals 1. So it will be m. So the right hand side equals m. The left hand side also equals m. Okay. So the right hand side equals the left hand side. That's all about our session today about continued proportion. We will continue next session direct variation and inverse variation. I hope you have understood our session today. Thank you very much for watching, and goodbye.